Physics, part 234. Well, we've got a question on our example, and question number B is from F is equal to EQ, F is equal to 2.0 into 10 raised to 4 into 5.0 into 10 raised to minus 9 is equal to 1.0 into 10 raised to minus 4 Newton. Now it's your turn. The two metal plates 15 mm apart have a potential difference of 750 volt between them. The force on a small charged sphere placed between the plates is 1.2 into 10 raised to minus 7 Newton. Calculate the strength of the electric field between the plates. Calculate the charge on the sphere. Field strength due to an isolated point charge. The electric field due to an isolated point charge is radial. We have to mention that the point charge is isolated. If any other object, charge or otherwise, is near it, the field would be distorted. From Coulomb's law, the force on a test charge Q is a distance r from the isolated point charge Q is given by F is equal to QQ divided by 4 pi E0 r square. The electric field E is the location of the first test charge Q is given by E, which is equal to F over Q. Thus the electric field due to isolated point charge is E is equal to Q divided by 4 pi E0 r square, or E is equal to KQ divided by r square, where K is equal to 1 over 4 pi E. This is an inverse square law field of the force because the force varies in proportion to 1 over r square. We've got an example for you. In a simplified model of hydrogen atom, the electron is at a distance of 5.3 into 10 raised to minus 11 meter from the proton. The proton charge is plus 1.6 into 10 raised to minus 19 C. Calculate the electric field strength of the proton at this distance. Assuming that the field is radial, E is equal to KQ divided by r square is equal to 9.0 into 10 raised to 9 into 1.6 into 10 raised to minus 19 divided by 5.3 into 10 raised to minus 11 whole square. 5.1 into 10 raised to 11 NC. Now it's your turn. A Van Graaff generator has dome of radius 15 centimeter. The dome carries a charge of 2.5 10 raised to minus 6 C. It can be assumed that this charge acts as if it were all connected at the center of the spherical dome. Calculate the electric field strength at the dome's surface. Electric potential energy and electric potential. We already know that useful concept of the energy is in dealing with the mechanical problems. Energy is conserved quantity and thus a fundamental aspect of the nature. We can also use the idea of energy in electricity. We define electrical potential energy in exactly the same way as we do the other types of potential energy. That is the change in the electrical potential energy when charge Q is moved between the 2 points A and B. In the electric field is work done by the electric force in moving charge from B back to A. We define electric field as the force per unit positive charge. Similarly, the electric potential is defined as the potential energy per unit positive charge. The symbol for potential V is its units is the volt. If a point charge Q has the potential energy of PEA at the point A, the electric potential at that point is VA PEA over Q. We already know that the only differences in potential energy are measurable. We need to specify a convenient reference point to act as a zero potential energy and potential. In dealing with gravitational energy, we often take flow at the laboratory or the Earth's surface as zero. The measure mgh from one of these. Similarly, in the electrical problem, it is often convenient to take Earth potential as zero, especially if the path of the current is earth. The official definition of the zero of the electrical potential is the potential of a point an infinite distance away. This means that the potential at a point in an electric field is defined as the work done in bringing unit positive charge from infinity to the point.